Hello, welcome back. So today let us see Ozonolysis reaction. So till now in properties of alkenes is a big chapter. Okay, I'm just telling you before only. So in alkenes we have seen hydrohalogenation, and then we saw OMDM, oxidation, oxymercuration, demercuration, and then we have seen HBO, means hydroxyboration. Sorry, hydroboration followed by oxidation, and then let's see ozonolysis. Important reactions in alkenes are the first one hydrohalogenation, and the second one is the OMDM, third one is ozonolysis, and then the fourth one would be hydroxylation and hot KMNO4. So these KMNO4 reactions are very important. So these are the main important reactions, and there are some named reactions which will be the next important reactions, and then there are some other reactions like addition of water and addition of H2SO4. Once we do all those reactions, then alkenes will be done. Now let us see ozonolysis, which is a very important reaction. So what is the use of ozonolysis? Is ozonolysis helps in identification of presence of double bond in a given alkene, like between the second carbon or third carbon, or the third carbon or the fourth carbon, where is the double bond present? How do you find it? So ozonolysis is going to help you in that. So it helps in determining structure by degradation, means it is going to break the structure. The ozonolysis is going to break the structure, and you are going to identify the compounds and check where the double bond was there. Okay, so what happens in alkene? This ozonolysis reaction, so the alkene reacts with ozone, with CH2Cl2, okay, and then forms ozonides. Ozonides are very, very unstable compounds, okay. So these ozonides are further treated with reducing agents and oxidizing agents. So when ozonide is treated with reducing agent, some compounds are formed, and when it is reacted with oxidizing agents, some compounds are formed, okay. So when we are going to use reducing agents, it is reductive ozonolysis, and when we are using oxidizing agents, it will be oxidative ozonolysis. Very simple. Now let's see how ozonide is formed. Okay, so the ozone molecule, which looks like this, technically, like not exactly like this. So it is going to look like this. Okay, so this ozone will react with this, and then this double bond is disturbed, just like how it happens in OMDM. Okay, and then this ozonide is formed. This is called mole ozonide. Okay, and then what would happen? And on further addition of ozone, ozonide is formed like this. Okay, this is very less important, just for information purposes we are seeing this. Okay, so this is called mole ozonide or initial ozonide. This is the most unstable. Okay, so what would happen here? This bond is given like this, and then this double this those, what do you call them, lone pair is given like this, and this would be given like this, and stuff. So these rearrangements takes place, and then some recombination takes place, and then ozonide is formed. Okay, so it looks something like this. Now what let's see the reductive ozonolysis part. Now ozonide is formed somehow. Now you are going to add some reducing agent. So after adding some reducing agent, okay, so the reaction mechanism is not really that important. Okay, we can just directly go with the problems. Okay, so ozonide is first reacted with reducing agent. So it is called reductive ozonolysis. So whenever you are adding reducing agent, just remember this is the shortcut. Now wherever double bond is there, like C double bond C something. This is the question, like this something. Now just in place of double bond, just separate these two like this, and then put a double bond O. Here also put a double bond O. C, like this. Okay, just cut the double bond, put the double bond O. Simple. That is the shortcut for ozonolysis, reductive ozonolysis. Okay. So reducing agents. What are the different reducing agents? Can be zinc. Whenever you are going to see zinc, just close your eyes. It will be reduction. So zinc in presence of H2O, zinc in presence of CH3COH, or zinc in presence of ACOH. Zinc in presence of ACOH also performs reductive ozonolysis. Morely that is used. Okay, ACOH. Right, and then Me2S is also used. Okay, dimethyl sulfide. This is also used, and then two carbonyl compounds are formed. Like double bond O is there, so carbonyl compound only, right? Pretty simple. Now, whenever reductive ozonolysis, the trick is cut the double bond, put the double bond O. Simple. Oxidative ozonolysis. Oxidative ozonolysis takes place when you are going to react ozonide with a reducing agent, with an oxidizing agent. So here the oxidizing agent majorly used is H2O, water, or H2O2, hydrogen peroxide. Sorry. Okay, hydrogen peroxide. Now, majorly you are going to see this thing, hydrogen peroxide reactions only. So what would happen here is there is a catch here. The catch here in oxidative ozonolysis is you are going to just do the same whenever you are solving the question. Just cut the double bond and put the double bond like this. Now there are some cases where aldehyde is formed, where ketone is formed. Aldehyde is formed, a ketone is formed. Now, whenever ketones do not undergo oxidation, that is the catch here. So, ketone, you are going to leave it like that. And whenever you are going to get an aldehyde, remove hydrogen, put an oxygen in the middle. Addition of oxygen is oxidation, right? So, in oxidative ozonolysis, you are going to deal only with aldehydes and then just put a O with hydrogen. It will become OH. Okay, this will become OH. Now, what will be this? So, carboxylic acid is formed. See, I wrote here. So, in oxidative ozonolysis, ketones and carboxylic acids are formed. And two carbonyl compounds are, in the sense, two keto compounds or two aldehydes, or one ketone or one aldehyde, something can form. But here, if in case there is an aldehyde, then carboxylic acids are formed. And in case there are no aldehydes, then the product is going to remain the same. Okay, the trick is that only in aldehydes put an oxygen. Very simple. Okay, so ketones do not undergo oxidation, just remember this. And then aldehydes undergo, so carboxylic acids are formed. You can see an example here. And there is another small side reaction which is very important. This will again study in preparation of alcohols. So whenever you take carbonyl compound and use these reagents, so these are strong oxidizing agents, right? Oxidizing agents. I don't. Sorry. So these are reducing agents. So LiAlH4 and NaBH4 reducing agents. So whenever you are going to use these reducing agents, these are very important. We have seen this in alkanes also. Alcohols are formed. Just remove this double bond, put a hydrogen. Simple. So the reagents are LiAlH4 or NaBH4. Anything you can use. This is important. That's it. This is ozonolysis. Very simple, very easy. Now let us solve few questions on ozonolysis and then conclude this video. Very simple questions. Now, here we see this is the alkene we are given. Okay, propene. Now, first we can see O3CH2Cl2 means first ozonolysis is done. Means this will be the first step, and then this will be the second step. Here Zn is, you can see Zn means reductive ozonolysis. Okay, so reductive ozonolysis takes place. What you have to do? Cut double bond, put double bond O. CH3, CH. Put a double bond O here. Just add double bond O, CH2. Simple. Okay. So here you can see. Okay, let's not discuss oxidative ozonolysis here because it's going to be an ambiguous question. So here you can see reductive ozonolysis directly. CH3, CH double bond O and double bond O CH2 are formed. Okay, this is a reductive ozonolysis. Now let's see the next question. CH3C, this is phenyl group, and then CH2H5. Very simple. Reductive ozonolysis, what you will do? This will not be given in exam. The reagents will be given. So just remember the reagents. It's important. Okay, CHC phenyl group, and then double bond O here, and then CH2H5 is just lying there, and then a double bond O here. Okay, this will be reductive ozonolysis. In case of oxidative ozonolysis, it will be the same. Just first write both of them. CH double bond add. Okay, double bond O C2H5. Now here we can see an aldehyde. An aldehyde is there. So aldehyde is oxidized. Oxidized means just add a hydrogen. add a oxygen with hydrogen, and then double bond O, and then C2H5. Done. This will be your product. This will be your answer. Okay. And then we have the next question. Deduct ozonolysis. Pretty simple. Break the double bond. Put double bond O like this. You're going to cut this double bond O like this, and then a double bond O. Simple. Okay. These are the questions on ozonolysis. You can solve these very simply, and mechanism is not important. So in the next video, let us see KMNO4 reactions. Okay, right? Thank you and have a nice day.